Okay, I think we're started finally. Here at the Forge, we've got Ron Craig, Pete Soper, Nick Edgington, and Dawn Trembeth. Who do we have remotely?
Haven. Hey.
And Jamie. I see. Okay, I finally figured out. Yes. Okay. So we've got Jamie, and who is N? Oh, that's Nick. Okay, so that's everybody. As I was saying, Paul McDougall said he'll be late. We hope that Carl will connect, but I think he has indicated some conflicts on Wednesdays, so perhaps that's what's going on. So I've got the agenda on the screen, and don't have anybody new, although Ron hasn't been here for a while, so welcome back, Ron.
Thanks. I've been joining remotely. I think I missed
that's
just
right.
The last one.
Yes, my mistake. Sorry. You haven't been physically here. So we've got quite a lot of agenda items. One of the things we wanted to show was the operation of the current Edge release from November that was put into flash drives and also arranged for installation on Linux systems. Relevant to that, I'm going to go to farther down on the website. We've got very detailed instructions for using the Rev2 dev board, and Ron and I can talk about his Rev1 board. It should be quite compatible. And Dawn is breaking this blog posting out to a PDF file, similar to the hardware instructions for the Rev2 dev board, and it'll be more convenient for folks to go through as a PDF. But I'm not going to go step by step through this unless folks would like to see it run. I can show you Edge running right here. The current system installs onto the desktop with 3 icons. One for changing your Wi-Fi. In fact, I should start that because it's going to have to rebuild Ant, so should get that going. And oops. Sorry, my speaker turned back on. So the first, so this is designed to be really, really easy to use. The first icon, when you double click it, brings up a simple little interactive session to customize your Wi-Fi, and we do want to do that. And if I remember right, it's Forge BFF-5G. Oh, no, I can't get it up. The Forge BFF. All right.
And this is because something in here is creating an access point that you need to attach to?
Yes. So it's the whole premise is that the Wi-Fi capability of the ESP32 has to talk to code running in your browser on your computer.
Right.
And so they both agree to use the same Wi-Fi local area net. So laptops already using that. You shows only the first letter. Yeah. Okay.
FF is under.
Okay. So that's rebuilding. One flaw in the setup right now, it should put out a little line right there that says, this is very misleading. It says, okay, you can now compile a project. Well, the script is continuing on and building it, and it's missing a little message that says, hey, it's building it. Give it a few minutes, and then as soon as this is done, it does put out a little message that says, okay, you're done, hit enter to continue. So that customizes your ESP32 board to use the specific Wi-Fi. And
the intention is to be able to provision the board through the serial interface directly without having to rebuild code. At the moment, it's hard-coded into it. There are all sorts of provisions in the experimental code that connect in directly without having to go through the rebuild.
they're not folks, they're not doing that. Yeah, so eventually the firmware in the ESP32 won't have to be rebuilt unless you want to customize it or upgrade it. So while that's working, I'm going to show you the second little icon. And this independently starts up the node.js server that is running on your computer, and it's serving JSON to your browser when you point it to your own computer. And the shorthand for that is localhost port 8080. So we're using port 8080 rather than the standard 8000. And you'll see that in just a second. So eventually we will be able to serve this code from a server out on the internet.
Right, I think we talked about that. It would be
Actually,
something
that's
a vendor could do,
Yeah.
make available.
Yeah, that's in the code. There's a way you can do that from, but you have to have a server to run it. So you have to be either running Apache on your laptop or move it out. And with the Edge server now seeming to be somewhat stable, we can move this out almost immediately.
Okay, so that's ready. So that's running, and as soon as and the rebuild of ANT is finished, and so in theory, we're talking the ESP32 is available to communicate, and so we're going to go. We're leaving the Aardvark JSON code running. And we're going to double click on the start browser, and it starts up and points it to localhost port 8080. And what's being served out is the Aardvark code. So that's now running inside the browser, and behind the scenes, this code has communicated with the ESP32. There's temporarily with the current code, there's a little protocol we have to follow using this test get menu and then dismissing it, and that properly sets things up. These bottom items, blinker, configuration, graphing, debug, those are hooks to features that are in development. They're not fully, they're not functional, but ESP_home is set up, and we can demonstrate both the connection to the Renaissance FPGA as well as the I2C interface. So if we go to the I2C interface, there's a spreadsheet-like display of values that correspond to all of the different I2C addresses. And if we use the scan I2C button, we don't get anything.
Well, why don't you do it?
I don't know. It worked at home.
Ah,
It worked. I would put money on the not having typed in the Wi-Fi correctly.
Well,
But let's see. Oh, we can test that. We can test that. Go back to this wonderful, amazing Perl command.
you can just ping it too.
Oh yeah, I can ping it. Yeah. Okay. So it's responding to ping, and let's see what it does with this Perl. That works. So, it isn't clear why the scan. Oh, I know. Another semi-superstitious ritual is this log out. And I'm going to do the test menu again. Yes, home, ITC, scan, ITC. Bingo.
Magic.
Okay, so it's also necessary, at least the first time you're using this, to use the admin button to log out and log back in addition to the test get menu. Those two are necessary, and I'm pretty sure those are in the instructions.
There's some cookies which store the IP address, and they don't write these buttons.
Okay, so now the other thing that we can show under the Renaissance is, whoops. Oh yeah, okay. Is to read a FPGA program, and in order to do that, we just use a drag and drop interface to drop the application file that came out of the FPGA synthesis tool onto the spreadsheet. And so we go down here to the standard place that the Edger repo is installed in is under the home directory in workspace /ESP32/Edger, and the synthesis files are hanging out here. This isn't, this instance of the repo that I'm using here is not off, it's not current, which is why we've got all these funny files. I didn't sync my copy. Anyway, if we can drag and drop this, there, it puts the FPGA code in place, and then if we click the flash ROM button, you guys probably can't see it on the camera, but the yellow LED is flashing, so it's running the Blinky FPGA program. in theory, Ron,
Should be able to do the same
your
thing here.
board should do the same thing, because when the ant code, the firmware code comes up, it sees that you're not using a, oh boy, no, I just thought of a roadblock. It sees that you're not using a C3, and it will properly specify the correct I2C interface. But I just realized that if we try to rebuild Ant, it's going to trip over the fact that your board is not a C3 board. It's one of the general ones. And we have to go in and tweak a configuration file to get you running. So we can do that at a later time. So anyway, so this is where we're at, and let me switch back over to the agenda. Are there any questions? Does anybody have any questions about this? Okay, so the next thing is to talk a little bit about the release cycles that seem to be taking shape. And the general flow is that Nick develops a new round of functionality or refinement of the existing functionality. He points me to a repository for what we'll call alpha testing. And then we're putting that into a repository to make it available for general testing. And Nick's going to show what's in the pipes. But what we're looking for are volunteers, for people to use their dev boards and exercise the existing and new functionality, and give Nick feedback about things that folks would like to see different problems.
The functionality Peter showed is the sort of crude space. I have spent a fair amount of time playing with the user interface and getting the skeletons working. But I have no idea what the user interface I've been playing with makes sense to anyone else on the face of the planet. And so I'm going to show it, and it's a skeleton. And then if this makes sense to other people, then I will feel recharged and delve into it. All of the pieces are there, but as I say, whether this is my view of a user interface, and it will surprise everyone that I have occasionally been wrong. And done things that gone down pipelines that make absolutely no sense. So I'm looking for what I will be showing is the general form of the interface, and what I'm looking for is this making sense to other people? Is this a direction, or should I just abandon hope and start again? Screw you all. I'm going to continue with it. But it's, and then what have I not put in that needs to be in? And there are provisions in there for help menus. I don't think you want me producing help menus because I know how to use it, so I'm absolutely no help. But is the general approach what needs to be added? I need feedback, otherwise I kind of I've been looking at this code for too long, and it makes perfect sense to me, and I don't like it anymore. So that's what I'm looking for. Am I on the right track? And, you know, if I'm way off base, then please, I would prefer to fight you about it, but wander down the wrong the wrong path and have just be nowhere. Do you want me to show my screens?
Yeah, so I was just pinging Haven or Jamie on the chat to see if they can actually hear us properly.
I can hear you.
Okay. All right.
Okay. Well, let me.
Okay. So next on the agenda is a demo of the coming features.
Okay. Let's see. That means I have to share
What?
my screen. I have to run things. There's no point on the machine. I might as well share everything. Screen sharing.
If you can generate more volume, that would be good.
I'd say anyway. Okay. Just so you understand how I go about things, the code I use the JetBrains toolkit, which I use because I know it well. It actually works very well. And so there are innumerable files here, some of which don't do anything, but most of which do stuff. And if I make a change here, it immediately propagates to the. Now let me log out again and log in again. I'll try and explain where I'm going. There is a configuration menu here, which allows you to turn on and off the bar on the left-hand side of the screen and have a different and exciting combination of colors. Let's see. What is that? I'll restart the code.
Usually just click someplace else on the.
Yeah, it's, I'm just not used to the screen. I have a slightly larger screen at home. Okay, now this page.
Your sharing stopped.
My sharing stopped. My God, what am I going to do? Oh, I know why it stopped. Recursion. Let's see. This one. Okay. This, the home page scans the local area network for objects of which are of the form. At the moment, it's esp-home.local. If there are multiple boards on the system, then you get esp-home-local1 up to n. I think I checked the 20 boards. This page gives you all of the information on all of the local boards that are out there. You have two options here. These are the two action buttons. There possibly could be a help action button. I have no problem with that. The information pen gives you all of the information about the local board. It gives you the IP address, And this works, if there are 5 boards there, this works independently for all 5 boards. It gives you the RAM, all of the information, and there is the concept of a friendly name, which is something, and you can actually add comments. I'm not going to do that now because I'm not. But so you've got, so you can have up to, I think it's 10 or 15 boards here that it will connect. That it will give you the information about any of those boards. This button here will allow you to connect to that board. So you can select which of the boards you want to connect to.
So when you say the boards that are out there,
Out there
how
in
do you
local space.
define?
Within the Wi-Fi.
Yeah.
In your, okay.
And there are provisions in here so that you can connect to a board somewhere else. So if a board is available on the web and you happen to have an IP address for it, then you can actually connect to it anywhere. At the moment, I'm running HTTP, not HTTPS, because I didn't want to troubleshoot all of that. But eventually, that's what the login page is designed to do, is that it makes it a secure communication. At the moment, the versions are not secure at all. So once you connect to a board, it comes up with an interface page. The interface page gives you any number of interfaces. At the moment, there's GPIO, I2C. I actually have provisions for serial, Bluetooth, Wi-Fi, and any of the interfaces that particular board has. In one version of the code, I have a GPS interface, so you can connect to a GPS interface. Under the interfaces, you have, if you hit I2C, it will list all of the I refer to them as instances, which are available on that device. Some of them may not be connected, but you will have a listing of peaks playing with a temperature sensor. You will have the BP 180. That is an interface device here, which could be listed as BP 180. You will be able to, right now, but you'll be able to select interfaces from the web. So you can say, you can go out to the GitHub account and you can say, I want to get Pete's interface for the BP 180. And that interface item will appear here. Now, this is actually an intense piece of code, but each of the interfaces has a separate information page that allows you to configure that interface. So in the GPIO, I can say I want to connect to GPIO pin 4. If you are on the I2C page, it will let you connect to any of the I2C ports. Let's see if I can do this. Oh, no, I can't. The I2C, when Pete ran the scan will be run from this page and will produce a pop-up menu that will show you what are the active devices on that I2C port. You can also, from this page, select different GPIO pins to be the I2C interface. So you could actually have 15 devices on different I2C configurations, different different clock and data pins. So this gives you the ability to have multiple devices. One of the devices you have is the dialog device, and it will appear here under I2C. These are all separately constructed dialog pages. When you select an interface, you again hit the connect button, and it will come up with a page which will allow you to talk similar to the Renaissance page that he was showing you, that will allow you to read, write, or display data from. So you've got three levels of menus, which are three levels of devices, which are absolutely symmetric. You have the interface. You could well have a help menu. You could well have. I mean, I've got context-sensitive help menu to some extent. I haven't fleshed it out, and I probably will rely on somebody else to do that. But this structure of the interface runs through the entire. When you get to the instance page, it might have a graph page, a gain page, or blink page. Each of these pages is in the code is a separate, actually a separate menu structure, a separate page. So you can build these pages. Let me. I don't know if I do that. I'll get back into Gypsy. Doesn't. This way. Okay, this. Back in. Page. Okay, tie screen. Yeah. Okay. So you've got in the interface page, for example, you have separate menu items that have all of the instance data for the GPIO or the I2C. All of that instance information is stored locally in that page. All of the menus are all stored locally in that page, so you can swap. I could in 4 or 5 minutes connect up another page. It's designed to be highly modular, so you can connect in and say
The developer of the Aardvark code can do that.
the developer of the Aardvark code. There are also provisions to allow you to essentially define an I2C interface and say, I want an I2C interface, I want the following gets and puts as a stream, and I want to repeat it every 15 seconds. And it will repeat that particular stream, and then you can go into the, when you select the instance page, you will get the data that is returning, and it can graph that data for you.
Does it introspect to figure out what they are, or is that coded by the person who's creating the I2C interface?
There are two types of I2C interfaces I'm dealing with. One of which is essentially the hard-coded, which is the Renaissance, and the Renaissance one, for example, has to be able to parse the configuration files for Renaissance. If you are dealing, there are provisions in one of the versions of the code that allow you to go to a completely unknown device. Say, I want to do put get. There should be a wait function and a query function. There aren't yet, but you can do put get wait, and then you can say repeat this ad nauseum and put it on this page. And so you can display the temperature data, the pressure data, and that's all done under the instance. There are complicated instances like the Renaissance one, which will be hard-coded. There are simpler ones which can be sort of soft-coded and shared, and there are trivial ones. If you're dealing with an impedance spectrometer, which is a fairly complicated instance, that needs to be reasonably well hard-coded in advance. If you're dealing with just a pressure sensor, then, that becomes a very simple example which will live out on GitHub. And it will allow you to import it very simply. Part of the charm of the system is we want to be able to go to other companies besides Renaissance and say, we can include your device and all of the magic stuff so that someone can very quickly select that interface and bring it up. And that is an approach to analog devices, TI, and all of the other folks out there. And it allows them to very quickly give somebody a link and be reasonably sure that they can do something quickly. The Arduino stuff doesn't allow you to do that quite as quickly. This gives you a web interface. All of the pages on the web interface can be chained or disabled, so you could turn off all the selection and have it go straight through and display data. So if you're dealing with an impedance spectroscopy unit or any of those things, I have a digital selectable frequency source that I have running, and so you've got a whole range of you could technically run any one of the software-defined radios inside of this environment. You can connect into it. This is also designed to be well beyond the ESP. I have not done that many experiments, but there ain't no reason why I shouldn't run the Raspberry Pi. It's the API. Pete's been playing with the API calls. The API calls are designed to be as simple and as clean as possible. There are issues with some of the offline storage, how much offline storage I have, where data is stored. Those are things. Some of them are security issues. Some of those are just space issues. But this, the actual ESP code, in the case of the ESP, is trivial, small in comparison. There are larger ESP units. In the case of the Raspberry Pi, it doesn't make less of a difference. You've got so much space. So that's where I am at the moment. I need, does this make sense?
Yes.
Oh, good. Okay. I mean, if it makes sense, I'd be kind of wandering in the desert trying to work out whether doing what I think I want, and that's the thing with my development. Now I got to, this is supposed to be a community project. Now I want people to say, no, don't like it, or I want help menus here. I'm not going to worry about the help menu things. I'm too busy in the deep weeds trying to get the fucking thing to work. But I need input. I need feedback. If only because I just sit in my corner writing code in case I need to talk to people.
I'm really thrilled about the GPIO capability.
Yep.
And also, I think that will actually speak to Ron's concern about getting youngins easily involved.
Mm-hmm.
And so.
And it is the GPIO stuff will allow you to blink an LED from the GPIO. That's what it's, I can connect in none of the dialogue stuff. There is, all the boards have an LED on it somewhere, and you should be able to blink that LED. You should be able to turn on and off a latch for a door.
Sure.
That's so the GPIO stuff is everything is done through the GPIO, and there are provisions that need to be put in there so you don't overload pins and all that stuff. But that's what the GPIO stuff is meant to be.
And the GPIO stuff, though, to be clear, doesn't really need the FPGA.
Nope.
Okay, good.
Yep.
So I've been doing automation with the ESP32s already. Things like water flow, using switching relays to turn lights on and off and all that kind of stuff.
And this is designed so you just put your relay on that thing and you can turn it on and off, and the dialogue stuff is one instance, and I refer to all the interfaces as instances. But you can go in through the interface, name its name a GPIO pin, and it will come up as that name, and you can say front door relay, electric chair, turn the electric chair on and off. And you can use the SPIR. I have a version of this which actually takes data from the Bluetooth GPS data from a cell phone and takes it in and tags any data you collect with that GPS data. Okay, this is not supposed to be a dialogue. The dialogue is just the friendly way in. That's where I'm trying to head, and I hope within the next, I hope by Saturday to have something for Pete to sort of begin to play with. All of the skeleton for the interfaces are there, and all of the context switching is there, and the code that I have, this thing will actually do the scans and all of that stuff. I'm not going to show it because it's very, very alpha code, but that's what it's meant to be. And it's meant to be something that if you want to add something that turns on the fuse to a nuclear bomb, you can put that in, add it fairly quickly, and it will allow you to do that.
What if the turning of the fuse, turning on the fuse requires some arithmetic? Where does the logic go?
You can do elementary logic inside of the AND. The AND has Poole asked for, and I'm beginning to produce for him, a thing that will read 10 A-to-D converter channels and pick the maximum channel. That is the logic on the AND, which is the ESP, uses a JSON string format, but actually is internally a really bastardized version of Lisp, because I'm a Lisp hacker from time when the dinosaurs were all the earth. And so the format doesn't use parentheses, it uses the curly brackets, but the interaction between the JSON is essentially syntactically Lisp. It's they're the same thing, basically. So it is as soon as I get the GPIO stuff, then you can I've got to make an internal change, but you will be able to say, turn on GPIO pin 3, do an I2C function, wait this long, do a conditional. I'm not doing the full list, but it's just designed to be a very, and I'm not telling anyone it's Lisp because they'll laugh at me. But it is.
Not if they were in computers before 89. Right. Well, they know.
Mid-80s.
Yeah. I had a Lambda, which was a hard-coded Lisp machine. I spent an inordinate amount of my life lisping. So, but it's also a very, I suddenly realized that JSON is Lisp. It's slightly different in that I have arrays, but it essentially is Lisp. And so the parser that I have for the JSON is, it's a Lisp parser, but don't tell anyone.
But to get to his question, if we want to do if this then that type stuff for automation, that sort of thing, then I do need that. I mean, today I do it because I write it as Python or I write it as C and actually run it on the ESP32.
You will be able to.
But I could do that in the FPGA.
You will be able to, when you send out, my intentions is not working yet,
Sure.
but there are puts, all of the API is puts and gets. You will be able to send out that's actually a patch command, which the body of which is essentially a JSON string which has conditionals in it.
Okay.
And that can be triggered, that JSON string can be stored in the user interface and sent out directly from the user interface with a single button.
Okay.
So Pete's been experimenting with the API. I use a tool called Postman, which I construct fairly complicated JSON strings inside a Postman, and then push them out. And there's no reason you have to use my interface.
Yeah, you can do that with curl. You can do it
He's been using curl.
But I think what we're going to need is some kind of functional reference into.
I need it too.
So for example,
Yep.
What we'll see in a minute, later in the meeting, with this temperature sensor, arithmetic has to be done on it.
Yep.
It's got these calibration registers, and you can't just read the temperature. I mean, you can read the raw temperature, but it's not guaranteed to be in any way stable and accurate. So instead, you have to do all of this arithmetic with the calibration registers. And the question is, how do we ping that within the XML/Lisp/JSON?
It is. There are two levels of communication. If you send out a JSON string or store the JSON/Lisp string on the device with the command repeat this every 500 milliseconds, then it will repeat, and because it all resides, and because it all resides on the ESP and is all passed on the ESP, it will be moderately fast. It's not blindingly fast, but it'll be pretty good. If you're going to do anything, and my intention is to allow simple conditionals, simple branches, but it is the ESP is not an ARM processor. It's designed to run simple code, and you could set up a conditional to send you an alarm via the response from a put or a get command. But my intention is not to run complicated code on the ESP. If you want to run damn complicated code, you do curl inside of Python, and you can run all of your complicated stuff. There is no. There are possibilities of bridging out, so you could run Python scripts inside of node.js, but that makes my body shiver. But it's once you're in the node.js world, you're running JSON script. You can get as funky as you want in that, and you can actually make calls out of that into Python. So it's where the boundaries lie. I'm determining that.
So I had kind of had it in the back of my mind, which I'm now bringing out and wondering if it's true that the FPGA was the place where I would do that type of
You can do
processing.
some stuff in the FPGA. I am also planning to add
No?
Go.
No, you can't do ads, you can't do floors.
However,
quotients.
I'm adding
Can't do arithmetic in it.
I'm adding a different FPGA, which is slightly more powerful, that will be in the same environment. And that will allow you to do things. I'm using the GoWin because they're cheap and GoWin likes me. But there's this, you pull that out, you plug in the GoWin board, and you then have a 10,000 gate FPGA sitting out there.
Right, but theoretically, you would have to synthesize a module for that FPGA
Yep.
that knows how to do arithmetic. And you're gonna cry when you have to do floating point arithmetic with it. Would it make more sense to be able to extend the Aardvark JavaScript?
You can, that's the JavaScript uses a lazy load, so you can extend the JavaScript to you can dynamically load modules and extend those to your heart's content.
So if there was a very simple primitive defined in the JSON object that's driving the interaction with the ESP32 ant, and that primitive says execute this JSON code that's out here somewhere.
That's how it works.
Then the user could put custom code in place. It could do this arithmetic we've been talking about.
The code to do that is lazy loaded at runtime. So if you need a particular module that does a particular thing, it will bring it in dynamically. It's
right, but to close the loop would require the end user, to be able to extend the.
They have to specify a JSON file.
Mm-hmm.
That's all they have to do.
And well, okay, they specify a JSON file, but how does that get hooked into the logic that's, for example, reading this I2C port, but called before this other I2C operation happens? How's that uttered?
There is a slightly weird concept of a shared memory. It's called a store, and basically you get a message through the whole thing when data has changed. So it is you, if you there are certain, I can show you, there are where's the store? The store module has the account information, and you have primitives which are defined as, so the actual, for example, if you look here, the ESP info command trickles down into this asynchronous store command, which and the store command has, if you say, async wait for ESP information, then that is the link point, and it will return. You simply define a variable in your code. Okay, let's see. Let's go to the ESP page. You simply define a variable name, which is okay. Okay. This, for example, will change will change something in the store variable called I2C set, which is the thing to set an I2C value. And then everyone that says, I want to hear that command can listen for that command, and they will get a dynamic in the next JSON script is single-threaded, but it does sort of a round robin thing. And at the end of each round robin, it goes out and looks for anyone that is listening for instance, in this case, is an ESP I2C set message, and that data will dynamically appear in that page.
So you just register a callback or a subscribe?
It's even simpler than a callback. You define a
Just declaratively, we just
yeah,
say, hey, I'm looking for this.
You define. I'm using. You simply define a variable name, and it essentially does a watch on the store thing. And when the store thing changes, the watch gives it a notice, and bam, your data is there. So that gives you. That's how that interface is, and this makes extensive use of that ability to be able to trigger asynchronous interlocks. So yeah, that's how the messages are passed internally. If you do, and this is all done in VUE, which is a sort of a well-respected Java dialect. You just define a. Let's see if I can give you an example. You simply methods mounted. You simply have an area that says computed, and these variables are automatically thrown into the watch list, and when they change, you will get a message. But it's all done through the JavaScript watch ability. It says, has something changed? Deal with it. And let's say you can watch any variable, but all of the variables to be watched in this case are in the stores directory. And they are asynchronously watched. And some of that requires a more than a casual understanding of JavaScript, which I have, but it's all well-established JavaScript. There's nothing, I'm not doing anything kinky to the code. My kinkiness does not extend to. So that's let's see. Computed. Okay. In this case, the headers for the interface are dynamically. They watch this particular variable, and if this particular variable changes, then all of the headers change. Now, in this particular case, I'm using that ability to detect that detect that one of these things has changed. So you're in a different interface. This button here doesn't, even though it's local to the code, sends a message through the entire system and then gets the message back that says that the interface has changed. That allows anyone to be aware of that. So even though the variables are apparently local, they are, they can be watched from 50,000 feet. And part of this is I'm still, the JavaScript is, I'm getting better at it. That's all I can say.
That's a challenge for sure.
Yes, it's a mess, but it has some nice semantic sugar in it. So that's sort of where I'm going, and hopefully people have some version of this to begin to play with. I would like, I mean, do we, I've got context-sensitive help here, but it's pretty primitive. But it exists in the code. I'm not going to make it any fancier, but if you want, do you want help menus? If so, tell me where you want the help menus, and then I will write in the hooks and you write the menus, because I ain't going to write them.
So we're coming up on, actually, did it say that the limit is 2 hours or 1 gig? The recording, well, it's run past 140, so it's still recording.
Okay.
I was expecting it for us to have to stop and start a new recording session.
So anyway,
Yeah.
that's where I am headed, and it was done essentially for my pleasure. Although it's getting to be a little bit of a drag. I need input. I need people to slap me around and say, I don't like this. I like
Sure,
this.
you've done the things that are obvious to you
Yeah.
to try to do, and you're like,
Yeah, and I'm bored.
Yeah.
I know what I'm doing. I know where I need to go. It's like I've been here before. Now, now tell me I'm stupid, and this gets me pissed off, and I get angry and do stuff.
Right.
That's the way I work. I'm sorry.
No, that's fine. I understand that.
Yeah.
I've got a basic understanding question,
Could you turn off your screen share?
Okay.
and that is, so I'm trying to wrap my head around how a person uses this. So I sit down and I've got a goal in mind. I want to make a software-defined radio, and I think this FPGA is going to be smart enough or sophisticated enough for me to be able to do some of that.
Mm-hmm.
Yeah, I know, I'm insane, but whatever. So I use the synthesizer,
Mm-hmm.
and with that software, which is not something we were messing with.
Right. Yep.
All right.
Or you could use the Go-In software or the Intel software, but at the moment it's the Renaissance software that we're using.
Okay. And then this system is able to suck that up and send it to the FPGA,
Right.
either temporarily or permanently,
Right.
to create the device that I want.
With
Correct.
the permanent aspect going into the non-volatile memory of the FPGA is still in progress.
Okay, but in theory, that's our eventual
And
goal.
it is, and you will be able to store a number of different software-defined radio configurations inside of the ESP. They come up when you're on the interface tab because it reads those from the FPGA. So you can say, I want software-defined radio number 6, and that will come up and allow you to connect to. So you have. There are some of the Renaissance stuff that has it doesn't have EEPROM, it's a write once.
Okay.
But you can still write to the RAM on the thing. So you can store the information, you can store a configuration in the ESP memory and say on startup, load that up. And that gets around the write once capacity.
Right, gives you a semi-permanent
Right.
capability. So when I'm using this, though, the point is not that I will at some point unplug the FPGA, go and embed it in something else, and have it run its own.
That's not my. There's no reason you can't do that.
I could do
As
that.
soon as we can write to the EE.
Yeah.
Okay. But in general, what we're thinking about right now is that ESP32 is going to be there, and we're going to be talking to it from a web browser. So I'm thinking about, all right, I want to do like Blink. I don't know if you've ever seen Blink, B-L-Y-N-K. It's an automation, Internet of Things thing for your iPhone or Android devices. So I can make some buttons and dials and gauges and so on, and it goes off and it talks to an ESP32, for example. But for it to do that, usually, for that particular one, you have a server running someplace that you pass your commands back and forth. Since it's got Wi-Fi on it, you can actually build a fairly primitive server right in there. You just serve up a couple of buttons for turning things on and off as well. But your user interface is not going to be very sophisticated in that case. It's going to be pretty primitive. And I'm trying to understand how and if this relates to that sort of world at all, because I'm trying to work through things that I vaguely understand. Plug this in.
I have not used that. The intention here is that if you want to put a user interface, you have a very sophisticated JSON script extension, which is the VUE extension, and you can through that VUE extension you have full access. It took for me to add, for example, the GPIO tab here took 5 minutes, and that gives you all sorts of pretty sophisticated, the ability to do this, gives you a whole bunch of pretty sophisticated things. You have a very, very rich environment in terms of being able to build your interface. And I've tried to reduce the ESP stuff to the bare minimum to be able to do everything that I think I need to do. So it's a little more than the drop and drag. There are a couple different drop and drag, type things.
This is used to have a palette of controls and you
right.
drag
This is designed, as a little more sophisticated than that. Although there's no reason you couldn't incorporate some of that into here. It's all of those will make put and get and patch commands. So there's no particular reason why you can't do that, but this gives you a far richer environment.
Okay. Final question from me, and then I'll shut up, is all of this we're doing from the laptops, from a browser.
Yep.
And that browser is running the JavaScript and so on.
Yep.
Do we have any thought of running this from something like an Android phone or iPhone browser?
It runs from Android phone now.
It does? Okay.
It does?
It does.
Show it.
I'd have to set it up on. It runs from. All I have to do is to set the move the file into my Apache server, and it runs. It runs from the Apache server. Okay. So it's a stock interface. It will run this code. I've done it. I move it out to my Apache server. This code is pure JavaScript and runs. It doesn't care what you have for a device.
Okay, very good. That's what I was expecting.
Yeah. It's the interface file produces a where is it? Produces a directory here. What's it called?
I think, but the node.js has to be running someplace.
Right. Well, the node.js is running on your local. If you're running on an Android phone, your Android phone supports running on Node.js. It supports JSON. if I move this out, if I build this to run on an Apache server, then all the Apache server is doing is serving JSON script to whatever device.
JavaScript?
JavaScript to whatever device you have. It does not care if the device, and Android devices and iPhones and iPads and anything else you want, all support JavaScript.
Because the node.js is just serving up static
Right.
data.
All right, but even more fundamental than that, at a previous meeting, we discussed the notion that there is some alternative way of building Aardvark such that it is a simple static page. That it is.
Yep, I can.
We haven't been able to do that. We haven't.
I've done it.
We haven't
Yeah,
found.
I haven't demonstrated it, but I've done it.
Okay.
I mean, if I go in and.
Well, get mad at me and show me that.
No, I mean,
So no, wait, let's just describe it. So what you're saying is that changing the let's say the flavor of build
Right.
Aardvark
you can go from the development build to the distribution build.
to a distribution, and one of the side effects is potentially a simple, not a very complicated page, but one that you
A large monolithic page with all the
Right.
JavaScript
a big
stuff.
blob of page that you can then put. You don't have to put it in. You don't have to use Apache.
Nope.
You can just put it someplace, like on the edger.app server.
Mhm.
We just stick it in a file. It has its own URL.
It has an index page.
You click on that, and you're effectively doing the same thing now within your browser, pointing at that URL as pointing to the node.js instance and referencing it with localhost. The thing to keep in mind, and keep repeating, we have to just keep in mind, there's a difference between it's possible for this to happen and this is now available.
This is now available.
So no, this is not now available.
It is. I can run it. I don't have it on this machine because I don't have a server on this machine.
And I rest my case that this is not available.
Okay. Well, I can.
And so the delta between these things, for example, programming the EEPROM and so on, they involve time.
Okay. Well, I'll try and do it for you right now.
No, I'm trying to kind of make a point that one of the other flavors of feedback that Nick needs is the means of prioritizing things and the sense of what the hot buttons are. This single static page, in my opinion, is a major hot button because it solves the problem of how to use this thing with Windows.
Mm-hmm.
We've been poking around at how to make this work on Windows, and it requires an environment, a set of tools called NVM, PNP, and NPM and PNPM that seem to be extremely hairy in a Windows environment. And as we've already promised Paul, who's a very Windows-oriented person, that he can have this page, but having it and saying that it's possible are two separate things that can be separated by minutes, days, months. So prioritizing is another piece of this.
Right, because we could sit here and spitball a bunch of cool things that we could do, and he's going to get excited about some subset of them, probably a very tiny subset.
Yeah.
But we don't know. We need to think hard about what the people that whoever our audience is, is really going to need and want to have.
Yeah.
And to me, it was very important to learn just now that the node.js application isn't doing computations. It's just serving up this material.
It's literally providing the web interface in conjunction with ESP32. ESP32 is very, very involved in dictating what the JavaScript code does.
That's the model, the controller, and the
Well, I'm not sure.
well,
I wouldn't go that far.
okay.
But it is designed where the
It knows what to ask for.
and the ESP32 basically says, I've got this stuff. And then the Aardvark code running in the browser knows how to make that available to you with these interfaces, on the web interfaces. So
This has been very helpful. I appreciate it. It helps me to understand a little bit better what the boundaries are here about what we're talking about. Because I continue to struggle to try to draw a diagram of 5 boxes
You struggle,
that
yeah.
have,
you're not alone.
that point to, who's doing what. Because at some point, my thing is security, too, there's my day job. So at some point, I'm gonna want to build a threat model for this and understand.
Okay,
When I ask you for something, how do you know it's me? How do I know I'm talking to you? And how do I know what I got back from you is what you sent to me?
okay, it's running on the web server now. It's running under web server. I just recompiled it, production.
Okay, so you've got a file that we could throw
Yep.
on edger.app.
Yep. It's a series of files,
You
some-
could, let's see, what would be the simplest way to do this? Put it on thumb drive.
Sure, I mean, I can,
Put the file on this thumb drive and I'll put it on edger.app.
okay. Paste it.
One of the things, oh, you probably know the answer to this question. So the edger.app is now running on the same server that is serving TrimeBed.
Okay. So
Now,
different virtual host?
no, it's the same host. And to make things confusing, the hosting of TrimeBed is changing. One of the guys, Jonathan Hunsberger, is going to take over the hosting. So TrimeBed.org is going to move to another server, but at which point edger.app will be sitting there on that server. But in order to put files onto that server, I have one magic SSH password.
Mhm.
Is there a way to give somebody else the privilege to put a file on the server, perhaps in a like a sandbox, okay, you can put files and pull files off of this directory on the server. Is that what I still see references to FTP, SFTP?
Yeah, you can certainly do that, and or secure file copy, and we can have those with certificates so that
Yeah, see,
we
with
don't have to pass passwords around.
the problem with, and I use secure file copy all the time. That's what I use. The problem is that the scope, when the secure file, when you specify a destination, it's the absolute root directory, and you can access everything. And what I need is some scheme that allows any of the other people that are involved with Edger to put things into, like say, we can just have a directory that's called
Shared.
Edger shared or something.
Sure.
And then the only issue is that if someone accidentally sticks, an overly large file in there, then my ISP yells at me and says, you're using too much space. And I actually, if it gets close to the limit, it will immediately impact they can literally clamp down on the operation of the server from my point of view. But that's something that I'm on the lookout for. Hey, Haven, you know everything.
Do I?
Have you listened to this all? I'm wishing for something like secure copy, SCP, to a server, but something that's somehow configured so that it only can access a fixed directory on the server instead of being able to see the entire system of the server.
Well, if you have a user, create a new user that has access only to a certain thing, and that's the one that you hand out, then that's the only place they can put it.
Yeah, the difficulty is that there's only a single user defined on that server for everything. The entire server, the server hosts several domains. It's trampet.org, edger.app, and 3 or 4 other domains, and there are some subdomains. But from the system administration view,
The people that own the hardware.
well, I don't have godlike powers across the. There is a container that's running. So my server is logically a container session. So when I log on, I can get hints about other uses of the machine, but only hints. I mean, generally, I only see myself, I only see my own processes. But I happen to know that server is actually hosting, dozens to hundreds of other users. So anyway, you just made me realize I should just ask my ISP.
All right, I was going to say, so is the concern that if we wanted another ID or something, they're charging us more money, or?
No, I don't think so. It's really, I think it boils down to there's probably a very simple solution, and I just need to ask the people that know for this particular environment, how, because other people will have this problem. Up until fairly recently, there hasn't been any need for this.
Sure.
So,
It's not letting me write to this.
there's nothing magic about that. It doesn't even have a write protection mechanism.
I tried to write to it.
My laptop won't either, that's because IBM owns it.
It's,
Now shall not write to a flash drive.
They will not flash drive. Okay.
um,
Well, while you're working on that, let me go to the next agenda item, and that's to demo HTTP endpoints, and basically, oh, good, I'm already set. If you guys want to use a really decent Linux system, try Ubuntu Make. So I have 4 virtual desktops, and I can swap between them. So this desktop just has 2 terminal sessions. This one's got Signal. This one's got 1. This one's got web browsers and all kinds of stuff on it. Anyways, it's a very
automation over there, something else over there. Some diff code stuff
so
there.
he's got the same feature over here.
That's a Windows box.
Oh, with Windows. Very good. Windows, it's the year 2023, and they have virtual desktops now. Okay, so what I'm going to show you is a very, very basic interface that the ESP32 runs. It does not involve Aardvark. It doesn't involve your web browser. It's just you and the ESP32. And by the way, this cable that I have plugging in is only providing electricity to the ESP32. So if you had one of these power pack things, you could run the ESP32. There's no communication going on through the USB. It's all Wi-Fi. There's a command on Linux systems, and there might be something analogous on Windows called curl. And I don't know what. Does anybody know what curl stands for? It's obviously URL, and then it's got C, like maybe it's command URL or something like that.
Command line URL.
Command line URL, very good. And what curl allows you to do is the same basic operations that you would ordinarily do using not necessarily a browser, but perhaps an application that is using REST APIs to interact from one machine to another. So notice this ESP-home local name, that's the reference on the Wi-Fi system to this ESP32 that's sitting next to me. And underneath that, within the addressing scheme of the ESP32 as a server, there are URL details here that specify a specific endpoint. And Nick has labeled this with the API label, but then notice the next thing down is a version, and he's specifically designed that in so that he doesn't paint himself into a corner if he needs to change API versions. He can do that without there being an either-or situation. I mean, they can both be accessible. And then underneath that, he's got a further specification to the I2C subsystem that the ESP32 can access. Then after this is a primitive HTTP operation to, and I should mention, this whole interaction with the ESP32 is done by a request method called patch. And patch is in the same family of commands as put and get.
I just felt casted that particular day and said, I'm going to use patch, screw you all.
And the difference is that the patch allows you to partially modify an entity. And so in this case, we're telling the server that's sitting there minding the I2C interface that we want to do a set command, and these attributes within the curly braces specify the details of that set. So the code in the ESP32 recognizes a keyword called address, and that's the main I2C address of the specific peripheral, and this is number 8, which happens to be one of the addresses of the FPGA chip. Index is a register address within the address space of the device at address 8, and then there's a length keyword that indicates the length of the data that we're sending, and then there's a data keyword that has as its value, instead of a single number, it's got an array, and this just happens to have one element. So this could be arbitrary, well, not quite arbitrarily long, with different comma-separated values. Then there's this magic ampersand that connects to another operation called get. And as you might guess by intuition, get is going to, I should say, the effect of this set operation is to cause ESP32 to send this byte of data down the I2C bus to this address, telling the peripheral that's at that address to send it to register address 150. So then the chained against along with this set is a get operation that happens immediately after the set. And this fetches data, and we're telling it that we want to use the same I2C address. We want to use register address 0, which is basically, this is pulling the entire contents of the memory inside the FPGA chip. And the effect of this is that the entire array is returned, and I'm going to show you what it looks like when you run it. Whoops. Oh, great. What did I do wrong here? I'll tell you what. Let me go back and get the original. Oh, we misformatted it. Oops. Oh, okay, let's try one more time. So this is the same command, but it's not as easy to read. And so we executed the curl command, and it sent the set command to the ESP32. The ESP32 responded that the set command terminated OK. The next thing was the get, and in response to getting the get command, the ESP32 has returned all 256 bytes of its current memory contents. So, as you might guess, this is a very, very general interface. So, the remote folks probably won't be able to see this, but on my dev board, I've got another little board plugged in. This little tiny blue board contains a Bosch BMP 180 barometer and temperature sensor. And this, well, let me go down here. So this sensor has a different I2C address. It's hex 77, and this variable called BMP I2C address has that value. There's a register within the chip that's just symbolically the control register, and then there's a command that goes along with that. In other words, we're sending 1 byte of data to this register at this I2C address, and that byte of data says, give me the raw temperature of the chip. So we then turn around and do a get, and behind the scenes, this is invoking the curl command, and it's packaged that up. I'll show it to you in just a second. And then the next thing we do is call a function that does a get command, which says, here's the I2C address, here's the register address, and here's how many bytes that we want you to read. Now what this looks like in a little bit more detail is the get value function checks its parameters and yells at you if you got that wrong. And then it's invoking curl with only the get API endpoint. And you can see it's the parameters to this function are referenced as $1, $2, so on. And so you can see that it's passing these values to the get command, and then it turns around. Oh, I'm sorry, I didn't show the set first, but it's exactly the same. So it's passing the parameters, and then for get, it's doing the same thing, and then it turns around and gets the response of the curl command and does hideous things to the output. You saw this output. basically, this is not the way to do this. Okay, I'll fill that in a second. But it's having to extract these numbers and build a 2-byte unsigned integer out of the two numbers. And going back here, it's fetched that value and assigned it to variable ut. As mentioned earlier, the BOSH makes it extremely involved to get an accurate temperature. You have 4 separate AC6, AC5, MD, and MC registers are read when this thing first starts up. It reads out those. It fetches those registers using the same curl mechanism, and then a whole bunch of arithmetic has to be done to end up with the accurate temperature. And in theory, this will work. And we'll see the current temperature. I'm astonished that it's 79 degrees Fahrenheit in this room. I would have guessed less, but it's pretty accurate. If I put my finger on the temperature sensor, you'll see it jump up immediately as my finger warms it up, and then it'll cool back off. So this is the absolute kludgiest way that you could accomplish this. The proper way to do this is to use Python and to use Python interfaces, libraries that understand JSON and that understand HTTP. I guarantee you that there are libraries out there. I'm sorry that Carl's not here because I believe that he's very, very familiar with this part of the world. And it would probably be a program of maybe 20 or 25 or 30 lines, most of which were the silly stuff that you have to do with the calibration registers and so on to get a temperature reading out of the chip. But by using a Python JSON library, you can pull this. You can build these detailed character strings that are ending up going to the endpoint, and likewise properly break out the results from a return JSON string. So, but there are endpoints corresponding to the different kinds of interfaces. There will eventually be, it'll eventually be straightforward to access the GPIO pins, for example, do your relays, turn on your water sprinkler or whatever. And so this is an alternative way to control a specific ESP32, and I believe in theory it can eventually be using HTTPS and provide it like an alternative way to implement an application, because unlike the current Aardvark web interface, there are places here, obviously, where you can hook in your logic. So you can get your program logic in place, and the operations that are supported by these endpoints are the same operations that the Aardvark interface is using. It's going to these same places via patch calls, and the difference here is that as I say, I mean, you've got a way to in a straightforward fashion to connect your logic, your program logic. On the other hand,
Have another.
it gets very complicated very fast. And so what might be the ideal would be for some of the Python programmers. Sure. Thank you. For a Python enthusiast to give us some abstractions that sit above the JSON libraries and the HTTP request libraries, and allow us in a simple fashion to say, do this I2C operation and now do the next one and so on, where what the user looks at, is like something like this. Oh, I've got to call a function with 3 parameters to do a set, and with 3 parameters to do a get. Now, one thing I should mention: this thing is very, very dumb. It only knows how to do unsigned integers. I do have a trick. There's a function right here for switching the unsigned value into a signed value. But my point is that Edger enthusiasts could do the grunge work to deal with the JSON and HTTP patch operations, and provide the rest of us a library interface that just provides the most general and simple view of the I2C bus.
Yeah, so that exists already. So there's a Python RESTful API library.
Right.
You just tell it, these are the values set, these are the values you get, and it turns them into
Right.
or floats or whatever it is.
Good. Right. So
does that for you.
Mm-hmm. And so if it's already JSON aware, if what you just described is at a higher level than the JSON, then
So
that's the way it should be. It should be
JSON
invisible.
strings back, and it'll just walk through it and make yourself a dictionary.
Okay.
Whatever the name value pairs are, just make your dictionary.
Okay.
Name value pairs.
Okay.
I sent you an email. It's on my Google Drive. I couldn't write to that for whatever reason.
Okay.
So it's
That's very interesting. Let me see. We've actually run over time. And why is this thing? It's still recording.
It's also recording longer than we've been meeting, but that's a different story.
How is that possible? The clock's running faster than reality.
well, we're obviously traveling. It's time compression. It's
Well, maybe it's Bing. Did you read recently that Bing can't decide if it's 2023 or 2022?
Yeah, I
It will
saw that.
argue with you. It will gaslight you to convince you that it's 2022. Anyway, yeah. So we've run out of time. If folks want to stay for another few minutes, I'll see if I can.
So let me ask a question about this board. So we've got several versions of boards now.
Well, we have 2. Yeah.
Okay, 2. I wasn't sure how far it had grown. So you've got a V2 board there, and I've got some sort of.
And I built 2 of V2 board.
Okay, you did.
And I didn't have the presence of mind to bring it.
Or
I think you should keep it as something useful. Because, as I mentioned, the only thing that occurred to me that you have to do to use that instead of the V2 is to change a parameter in this file, in the ant directory, and you just make that change once. You would have to have your instances separate to go back and forth between the Rev 1 and the Rev 2. And then just, and it's to tell it, this isn't a C3 board, this is an original ESP32 board. And it knows to use the correct pins to connect to the I2C bus and so on. So it should be absolutely usable, and the people that have the version 1 boards should hang on to them and get their
The C3 is just ridiculously cheap.
get their watering systems running or whatever it is that they would like to do with it. So let's see if I can get his file.
It was, the C3 is ridiculously cheap. They've come up with a C6, which is much faster, and they're risky machines, which seem to be a good choice to use.
Yeah, I think we need a microphone that's closer than the camera.
Oh, just just go buy a Bluetooth mic and.
Yep.
Have that here, set it down.
So, let's see.
It's like mine.
Oh, it's a bunch of files.
Oh yeah, no. It's it has an index,
Okay.
which is the top level, and then
Here we go.
Whoops. So it's a whole tree.
yeah,
Okay, so I just downloaded it.
Yep.
The dist.zip. And so if I unzip that,
if you unzip that and just click on the HTML index.html, it'll run.
Does it unzip into a directory, or is it just?
It should unzip into a directory called dist, D-I-S-T.
Okay.
And
So,
just click on the index, and
Yep.
it will.
that's what I'm gonna do.
And it should run.
Okay, let me turn this sharing back on so folks can see this. So, whoops. So, Nick sent me a file that has
Just
these.
click on the index.
So it has the index.html that is kind of the jumping off point for when you visit a directory with a web browser. By default, it goes through a set of conventions and it looks for various things, index.html being the oldest. And then these guys are all files containing all of the stuff. And when I pointed the browser, oops, wrong browser. There we go. Sorry, I'm oh well, I'll do it again.
Yeah.
So if we point the browser, oh shit.
You just click on the file from the file finder.
Yeah, I could do that too.
Yep.
Let's do that.
It'll save you headaches.
There.
Yep.
And so now this is
That's my version.
this is Aardvark running, and so we can install this on Edger.app, and Paul should be able to launch it from his Windows system. Let's see.
Yeah, all those package managers and
Let me-
things that were giving you trouble is just really there for getting the.
Let me put this on Edger and let's try it.
Please do it.
Sorry, I'm losing my mind here. To do that, I'll type the URL in. Oh, it's already done. So now we'll go to edger.app.
Did you use the dash mark to do the entire directories?
Yes. Oh, look at this. Use, oh, never mind, that's an artifact. There. So, is this running the?
This is my latest version. I just, that happened to be where I was.
Okay, so we could theoretically build this corresponding to the current release and make it available. But for people that want to experiment, I'll put this in chat.
I was able to get there.
Oh, woohoo, you're running it. Okay. So
Yeah, it's a highly experimental version, but that happened to be the directory I was in.
Expect smoke to escape.
Yes,
Yes,
oh yeah,
yes.
this is his development build, and it's what he was demonstrating earlier, and it does not come with a warranty.
Yes. No, it's guaranteed to be broken.
Right.
Yeah, it's I just simply pull that unabashedly from.
Okay, so how do I? Oh, yeah. It isn't clear that I can even access.
You
this one?
actually no. If go and you should. I don't yeah.
Well, the point is we can make this using the Edger repo that's stable and get it onto edger.app and publish the URL. But for the time being, people that want to just browse and see what it looks like can try this out. And I'm putting the URL into them eventually.
So, whose device am I looking at, or are you looking at?
You are well. You'll be looking at if you have a local device. You'll be looking at a local device because it scans the local directory.
I haven't found it yet.
Yeah, no, it's as I it's.
Don't expect to accomplish anything with this except to be able to browse it.
No, it's.
All right, where is the chat? There. No, it's not chat.
There we go.
There's the chat.
First time you go in, by the way, the navigation bar is not present on the setting. Turn it on.
This is weird.
The information there, that's also editing, right? Settings and properties as well?
Yep. As I say, this is
Okay, I put it in the chat window.
This is beyond bleeding edge.
Yeah, this is literally his development environment, and there's a whole bunch of stuff that's.
So that's running Aardvark, right?
Yep.
Yeah,
on
this
the,
is our,
on the server.
it's running on your browser, but you're fetching it from the server.
Okay.
And it will, in theory, although I have not tried this, it will in theory connect to your local device.
Using the MDNS.
Yep.
So I'm doing it right now, and I should see nothing, right?
I don't. You may connect to Pete's device.
But I'm not on his.
But you're on this Each
You have
device is on my,
Wi-Fi in the house, in the building, I mean.
and, you know,
Well, that
it's-
explains why I see it then.
okay, yeah, it's, as I, this is, but yeah, it will, you know, it'll connect to whatever devices are local.
Interesting.
Okay.
Now I put on my hacker hat. I'm like, okay, what evil can I do with that?
Well, it's HTTP, you know, if I add the S, which,
I know how to do that on the SP32. I can help with it.
yeah, no, it's, I just, I'm not gonna try and troubleshoot
Yeah, you
encrypted code.
Yeah, it's not, that's not important at this
Yeah,
point.
yeah, no, and
I'm gonna go ahead and stop the recording.
Okay.